Hello, our project in the course Introduction to Cryptography is based on data security using homomorphic algorithm. This project aims to research the application of homomorphic cryptography in the financial sector and evaluate financial data security. We have performed a literature review for this project along with its implementation. This is the basic architecture of our algorithm. First, data is encrypted using AES. Then the AES key is encrypted using Pyla public key. Then the encrypted AES key is shared to multiple parties. The encrypted key is then recovered from multiple parties. Then we decrypt the AES key using Pyla private key. And finally, we get the decrypted data using AES key. AES homomorphic encryption. It is a popular symmetric encryption algorithm used to protect sensitive data. However, it is not homomorphic in its standard form. In order to achieve homomorphic encryption using AES, additional techniques need to be employed. One approach to homomorphic encryption using AES is to use a technique called fully homomorphic encryption over the integers. It is a type of fully homomorphic encryption that operates over integers rather than binary data. Next is homomorphic encryption using Pyler. It is a common illustration which enables computations to be done on ciphertext without first having to decrypt them. It is a probabilistic encryption method that encrypts communications using randomization and modular arithmetic. A message must first be transformed into an integer m before it can be encrypted using the Pyler encryption method. We then additionally added an algorithm called MPC, which is multi-party computation. It is a cryptographic method which enables many participants to collaboratively compute a function over the individual private inputs without disclosing those inputs to one another. The parties utilize a cryptographic protocol to accomplish this, which guarantees that the computation is carried out securely and that the parties only discover the computation outcome. This is the implementation of our algorithm. We implemented this project using Python interpreter. This encrypts a text using AES method followed with Pyler method, and then decrypts the encrypted text back to its original form by decrypting it through Pyler and AES method. We will be explaining a few functions we performed in this code. Starting with the first code, encrypt file function, it encrypts the file that is a.txt using AES key. It encrypts the chunk and writes it to the output file. This is done by first asking the user to enter a password and then the AES key is generated. Here, the user is asked to enter the password, whereby the key is generated successfully. We then use parallel method of encryption to encrypt the AES key text. This generates a public and private key pair. Public key encrypts the data or text and private key decrypts the text. Decryption using parallel key is done only in integers and it does not understand characters. This encryption is done using MPC, that is multi-party computation. Parallel method basically divides the text into parts. Here the encrypted text from AES is divided into parts. Now each part has a shared key with the number of trusted parties n and its threshold value k. We have assigned here n with 3 and k with 2. We can assign any number of trusted parties, but that has to be done in accordance with the threshold value. Here, n is the number of trusted parties and k is the threshold value. The next function decrypts the AES key using Pyler. We continue the decryption. We first need to enter the password we set earlier before the encryption process. The decrypted key received after performing parallel decryption is same as the encrypted key we received during AES. We further decrypt the AES key to get the original text. Here, the decrypted text is saved in c.txt. b.txt is encrypted file using AES. We cannot open that file. A.txt and c.txt will be same, which shows the file that has been correctly encrypted and decrypted. Now, we'll be showing a demo run of our project. This is the a.txt file which has the data. Continuing. We enter the password. This is the AES key generated. The file is successfully encrypted and is stored in b.txt. The encrypted AES key, which is all in integers, is here. This is the trusted shared parties. The AES key recovered from the two shares are here. The decrypted AES key using parallel public key is given here, which is same as the previous public key, AES key received. We again enter the password. The file is successfully decrypted and stored in c.txt. We open the file and this is same as a.txt. Therefore, it is successfully encrypted and decrypted. Now we'll be showing. Now we will run and show when the password is incorrectly entered. We enter the wrong password. We get the message that the password is wrong and the file is not decrypted correctly. When we open c.txt file, it is not the same as given in a.txt, which is our original file. Both the files are different, therefore the data is not encrypted correctly.